SICKHACKS.root. I said I wanted to make a technical video for this game, and here it is. Sorry for the wait. But this should cover some of the more technical aspects of this Game Jam game. Let's get into it. Let's start with the prototyping phase. Using a tutorial, I made a very basic physics-driven hoverboard that uses forces to push itself off the ground, go forward, and turn using torque. It's not perfect. It has issues maintaining momentum and has a generally floaty feel. The implementation is fairly straightforward. The movement and turning is applying a force multiplied by the input, then multiplied by the transform's direction. Forward for forward, and up when applying torque for turning. A force is being applied towards the ground at each of the 4 anchor points on the board. The amount of force used is relative to the distance to the ground. That distance is calculated by a raycast hit from each anchor. This is then controlled further by a multiplier. I also have a piece of code that keeps the board upright. The first level is a curved downhill path with obstacles and ramps scattered across it. The level itself is a curve that has been extruded and cut in half horizontally. I did this in Blender and then imported it. Initial testing showed that this terrain did not play well with the previously existing code, so I made some changes. I implemented a waypoint system and placed these waypoints along the surface of the level. As the player would progress through the level, they would be rotated towards these points and a constant forward force would push them along. As you can see, although functional, the implementation method I went with initially causes a lot of camera jerking, which is unpleasant to look at. The most recent version available on the itch.io page has some changes which partially fixes this issue. The hoverboard code in regards to the physics remains unchanged. The waypoint system is fairly simple and just updates the current waypoint as you get close to the current target. I'm using a simple transform.lookAt call to get the player to rotate towards the target waypoint. It does not do this smoothly, however, and the new version uses slurp instead. It also affects the downward trajectory in a way that is somewhat unnatural. As previously mentioned, there is a constant forward force being applied to push the player along the level, and a gravity force applied that is active while the player is in the air to help tackle the floatiness that I mentioned earlier. Another problem I faced with in the first level was the placement of obstacles. Each of these props had to be individually adjusted to match the curvature of the level, which as you can imagine is a pain. Having a stack of obstacles next to each other made the process additionally painful, as you can see by some of the walls in the level. The colliders around the level are sloppy at best, and the player can break through them at points. Due to the nature of the level, it's somewhat difficult to fix this issue, but I am looking into solutions. Pulling off tricks on the board was found somewhat by accident. It works by separating the physics collider from the actual board model, and have the player model be a child of the ladder in the hierarchy. I then rotate the board on 2 different axes in relation to the input. When the player lets go of the input or lands, the board rotates back to the original position. I say it was an accident because I found it while experimenting with the add torque function of the rigid body. I applied different axes to the torque to see what different kind of effects I could get, and stumbled across it by accident. However, instead of using torque, as the models themselves do not have a rigid body attached, I simply used transform.rotate instead. For the second level, I ditched the curved downward level design and instead made the level flat. This comes with some advantages, most notably the easier placement of props on the level. I no longer had to individually rotate each obstacle for the level. This made putting stuff down much easier and faster, as batch placement and editing was now an option. I'm still using the same script, so the waypoint system is still here, but there's only one waypoint, right at the end of the level. Because of that, playing the level feels much smoother, as the camera jerkiness is no longer present. Because it's a flat plane, I only needed 2 colliders on the edges to keep the player in bounds. Learning from my mistakes from the first level, I figured a more basic design would end up being more functional. The third and final level is basically a cutscene. The player follows a track up to the top of the quote-unquote tree, and the game ends. This segment was somewhat complex to make. I had to extract and convert vertex data of a spline to coordinates on the rail model. I used a Python script to do this. This created a CSV file full of vector-free coordinates for each point on that rail. I load that CSV file as a text asset via the resources folder. I then split up the lines of the text asset into an array, each element being a string that represents a vector-free coordinate. However, because of the differences between Blender and Unity, I have to swap around the Y and Z coordinates on each vector. Once I have those coordinates, I have to convert them to world space. Before I do that, I rotate and scale the vectors based on the rotation and scaling of the model it's being placed on. In this specific case, it's being rotated by a negative 90 degrees, scaled up by multiplying 20, multiplying again by 6, and then scaled down by multiplying it by 0.1. I then use the multiply vector method of the matrix 4x4 local to world variable, and set the waypoint object's position to that value. As you can see, it lines up fairly well with the model. I still use the waypoint system for aiming the player towards each point, but I removed the hoverboard code and instead rotate the player using the look direction and slurping towards the next point. And then I use vector3.moveTowards to move the player along the points up the rail. Due to time, we could only have one rail. If we had more time, I would have figured out a way to swap between rails, like something out of Ratchet and Clank. Although I am fairly negative about the mistakes and issues in the game, I am fairly happy with what we managed to put out. But I have a question to ask you guys. Should I continue developing this idea? Since Global Game Jam, I've been thinking about this game, and I've been tinkering and tweaking it ever since. So if you guys are interested, I might sit down and properly design this game and fully develop the idea as a main project. Let me know in the comments. I stream on Twitch, I'll put the URL on the screen. Game dev streams every Tuesday, Wednesday, and Thursday. Also, you should check out my other games on itch.io, link in the description. And if for some reason you feel like throwing money my way, I'm on Ko-fi as well. And I take some commissions there, so check that out if you need something done. And I'll see you guys later.